Yeah, we're talking about what the world would have looked like when these rocks were being deposited. The shapes of these rocks now, they're forming folds. Rocks have been deformed, but originally they were pretty much flat-lying.
And that's pressure, isn't it? It's the pressure pushing against the rocks that folds them up and over each other. That's correct?
That's right, but that's a later story.
Okay.
What we're talking about now is what this area would have looked like when these rocks were being deposited. And as far as we know, you've got a couple of rift valleys, one through here, another one through there, maybe with some highlands in here. And over here, you would have had all sorts of things happening. At one stage there was some volcanics being deposited, some basalts erupting from through the crust, and they were very thin. They're just around the edge now and just going in underneath. After that you had some glacial deposits form. 2 periods of extensive glaciation that might have actually been worldwide glaciation. They were quite interesting. They're called the Sturtian and Marinoan.
Oh, so what age are we looking at there?
You're looking at somewhere around 800 to 600 million years ago.
The snowball Earth period of time. I've heard it described as if you were standing on the moon and you looked at the Earth, it would have been like a cue ball, a totally white ball with the ice potentially in the mile thick at the equator. Or I'd heard reports of that, like, you know, ice all the way to the equator, a totally white world.
Yeah.
And was it the volcanism that tore that apart? I've heard that that's a possibility.
I don't know the detail there. There's a lot of studies still going on about that sort of thing. First they have to establish that it was actually worldwide at the same time, and it may have been. And we're not quite sure what tore it apart. It could well have been the breakup of continents that tore it.
And we call that supercontinent Rodinia, don't we? It was the supercontinent, some people believe, that set off this extreme ice age, because perhaps some people have heard of Pangaea. That was a supercontinent, broke apart into Laurasia and Gondwana, but that was much, much later on in Permian times, and perhaps that had something to do with the Permian extinction. But Rodinia is a much older story, isn't it?
Yeah, this might be to do with the breakup of Rodinia.
Wow.
Yeah, so you had the ice ages, but in between the ice ages you had shallow marine conditions. You had shallow seas with limestone and dolomite forming, and just a lot of mud and some sands out there.
Now limestone comes from coral, doesn't it?
Yeah, but not this limestone.
Oh really?
The corals were much later than this. They started at about 500 million years. This is before the corals, and there's some remnants of stromatolite colonies in the limestones here. I've actually seen some.
Really? Where are they?
There's some distance up here around Corona, around this area.
Right, and stromatolites, as I understand it, are these colonies of single-celled organisms, and they were around for many, well, potentially billions of years, perhaps, and they had a lot to do with possibly, people have speculated, turning the sky from pink to blue.
Oh, maybe. Yeah, the stromatolites are basically algae that were depositing calcium carbonate that formed the limestones. But algae being plants, they're taking in carbon dioxide and giving off oxygen. So they're changing the nature of the atmosphere. And they're probably the organism that allowed us to develop as mammals and humans. You know, without the oxygen in the atmosphere, we would never be here. But the stromatolites are very fascinating animals. They've been around for about 3,000 million years. That's incredible. And there's still stromatolites living in the sea now in places like Shark Bay in Western Australia, living in the shallow water.
Okay.
You can still go and see living stromatolites. But anyway, we had shallow marine conditions through here, and some of it could have been quite warm at times after the glacial period. So we're looking at a very long time period through here, from about 800 million years to about 600 million years. That's a very long time period.
So that's why these maps are so fascinating and so exciting to people like us, because each one of these areas is telling a different story. The different stories tell us of a different time, a different way of imagining the world, totally different kinds of experiences for the surface of the planet.
Oh yeah, there's an incredible contrast here. In the early stages of this